Hello everyone, so I'm very happy to be here to introduce my works. The title of my paper is Robust Multi-Level Linear Discriminant Analysis Algorithm for Remote Sensing Image Changing Detection. This paper was accepted in the International Conference of Social Science and Computing Informatics 2022. So I'm the first author of this paper. My name is Tao Zhang. I come from the key library of urban land resources monitoring and simulation, Ministry of Land and Resources. It belongs to the Shenzhen of China. So this paper is about the changing detection. It has always been the focus of remote sensing technology research. However, the process is complex, involving image preprocessing, threshold segmentation, feature extraction, image segmentation, and classification. Current machine learning algorithm is often need more labeled training samples to get better performance, such as deep learning approaches, sparse classification approaches, semi-supervised learning approaches, where multi-level linear discriminant analysis has been proposed for the difficulty detection tasks. However, MLDA involves the agent decomposition of dense matrix, which is very expensive to compute on a large scale. In this paper, we demonstrate that MLDA formula can be equivalent to the least square problem, which greatly reduces the commutation of sets of high dimensional data sets. In addition, it is found that introducing attractive regularization technique into the least square model can improve the generalization. Then we can conduct that. Introducing attractive regularization technique into the least square model can improve the generalization. We conduct some experiments to indicate that our proposed model stands the competitive results compared with the state-of-the-art methods. Remote sensing image change detection refers to using remote sensing images and related data of same region in different periods to compare them through image processing, mathematical model, and other technologies, and to analysis involving data multi-temporal remote sensing images, and the performance of traditional algorithms decline. The image transform method based on feature extraction and mapping can effectively highlight the change information and has better performance of change detection. However, the change of multi-temporal images are often complex and the existing methods are not ideal. In recent years, deep network has shown excellent performance in feature extraction and projection. Therefore, this paper proposes a multi-temporal remote sensing image change detection algorithm based on deep network. In this model, the input data of the two-phase image is projected through two symmetrical deep networks, and then the slow feature analysis model is used to suppress unchanged components and highlight the changed components with transformed features. The changed vector detection method was used, and the invariant pixel with high confidence was used as the training sample. Finally, the trip distance is used to calculate the intensity of change, and the threshold algorithm is used to determine the change. More recently, remote sensing image pattern classification research has attracted more and more attention in GIS area. However, remote sensing image recognition is usually difficult due to the samples difference of the same class and time consuming, while on the other hand, approximate nearest neighbor topic has been advanced research area for its high and efficient retrieval performance on the large variation datasets in recent years. So, in this paper, we propose a novel shared subspace for multi-level remote sensing image data change. So the proposed least square MLDA, it is a useful technique for many recognition and classification tasks. Giving a data, the first is compute the left singular vectors of H to get the UH. And then we can solve the following least square problem. Above stamps indicate that MLDA is equivalent to least square problem. So, to access the superiority of our proposed model, we compare it with other existing approaches on three public datasets: ETM datasets, Taizhou datasets, and river datasets. We give these examples of the data in Fig 1. So from this picture, we can see that our proposed algorithm is used to learn a transformation matrix from training samples to map both training and test sample to a lower dimensional space. We use the multi-label k nearest label classifier to predict the labels of sample. Five-fold and cross validation was used for all evaluations. Repeat the process for all 9 permutations and average the results. Table 1, 2, and 3 show the average the performance of the 8 methods in terms of AUC, macro FE, and macro FE, respectively. Note that the results of MLDA was not reported in these tables because the equivalent one is the performance of MLDA has been proven to be comparable to LS MLDA. Computational efficiency of LS MLDA is much higher than that of MLDA. It can be seen from the table 1 and table 2, table C. So, the efficiency of LDA problem of multi-label remote sensing image changing detection is studied based on the equivalence of relation between FLDA and its least squares M formula. efficient erective conjectured gradient algorithm for dealing with large-scale least square problem can be employed to increase the computational efficiency. Moreover, some promising regularization technologies are introduced into our new least square formula, which greatly improve the generation performance. Detailed experimental analysis indicates that our proposed algorithms perform better than other comparative algorithms.